Okay, third years, we're going to go through the corrections of the homework that you had last night, and it was about rational and irrational numbers and the different types of numbers that we have. So for question 1, we were asked to state whether each of the following numbers were irrational. Square root of 7 is irrational. How do I know? Well, it has a square root sign and it can't be simplified. So not only is it irrational, but it's a surd. But also if I type into my calculator square root of 7 and I press the change button, I get a decimal that takes up all the space and there's no repeating pattern. The square root of 4, however, will simplify to 2, and that is rational. Okay, 2 is an element of Q. It's a rational number. 101 is rational. Okay, any whole number can also be written as a fraction by just putting it over 1. So if we were asked to give an explanation, we could say because 101 over 1 is the same as that. 3/5 is the very definition of rational. But then 3 minus the square root of 9. Now it looks like it mightn't be rational because of that square root, but you should know, of course, that the square root of 9 is 3, which means we have 0, and so this is rational. And in fact, the square root of 7 was the only irrational number in the question that we had there. So if you weren't sure about that last one, you could always just go ahead and type it into your calculator, 3 minus the square root of 9, and the calculator will give you 0. 0 is a whole number, and all whole numbers are rational. Okay, question 2 then. Just move this up a bit. So question 2. Say whether or not each of the following numbers is a surd. Now we must explain our reasoning. So a reminder that a surd is an irrational number with a square root sign. Okay, so we've got two things that have to be true. It has to be an irrational number and it must have a root sign in it. So I'm just going to do X or tick. The square root of 5 is a surd, and the explanation is just it's irrational and it has a square root sign. Part B, the square root of 64 has a square root sign, but it's not irrational. It's rational because the square root of 64 is 8. And that's a whole number, so it's rational. Part C, the square root of 19 is a surd because it's irrational and it has a square root sign. Pi is not a surd. It is irrational. There's no repeating pattern and the decimal goes on forever, but it has no square root symbol. So we need a square root for it to be a surd. I keep repeating myself. The square root of pi squared, not a surd. Okay, because the square root of pi squared is just pi. And we've already said that pi is not a surd. F, the square root of 2,500. Now if we're not sure, we'll go ahead and check in our calculator. 2,500 is 50. So that's a whole number, and that is not a surd because it's not irrational. G, the square root of 324. You wouldn't be expected to know whether that's a perfect square or not off the top of your head. You have a calculator. It is though, it's 18. So exactly the same reason as the last time, it's not irrational. So it's not a surd. H, square root of 648. Let's just check. Square root of 648, 18 root 2. So that actually is a surd because I have a square root in my answer, and when I press my change button, I get a decimal with no repeating pattern. So this is a surd because it is irrational and it has a square root sign. And part I then, just check that we're still on screen. Part I, the cube root of pi cubed. Now we've done that square roots and squares cancel, but we hadn't really talked too much about cube roots or other types of roots. So cube root means for example, the cube root of 8 is equal to 2 because 8 is 2 cubed, so it's undoing a power of 3. So a cube root and a cube will cancel, and that's just going to give me pi. So that also is not a surd because pi is not a surd. There's no square root sign when I simplify it. Okay, a few tricky parts to that, but hopefully it made enough sense. Now for question 3, we're asked to complete a table. So let me just sketch the table that they had. We had n. The book isn't great about doing the symbols properly, but if they're printed on an exam paper, they will have this extra line. You don't need to be able to do the line yourself though. It's enough to just recognize it. And r less q, my irrational numbers. So this is the table I need to complete. And I have to say whether the following numbers are in one or more of these sets. 8 root 7, 5 root 8, and pi over 2. Okay, it's only in the natural numbers if it's a whole number. So 8 is a natural number, but none of the others are. It's only in the integers if it's a whole number. So natural number if it's whole and positive. So 8 is also in the integers. And none of the others are any kind of whole number. So none of those are in the integers. It's only in the rational numbers if it can be written as a fraction. So we can write 8 as 8 over 1. So that is there. This is a surd. So it's not. We did that earlier. It's not rational. 5 over 8, it's already written as a fraction. And pi over 2, well, pi is not rational. If you're not sure, put it into your calculator. Pi over 2, and we see that we get a decimal with no repeating pattern. So pi is not rational. Now these guys are opposite. So if it's in Q, it can't be in R less Q. If it's rational, it can't be irrational. If it's not rational, it must be irrational. If it's rational, it can't be irrational. If it's not rational, it must be irrational. And that's how we fill out that table. And that's a kind of question that has come up quite a bit on the exam papers in the past. Now, let's look at the last question that I gave you. You were given a Venn diagram and you're asked to copy and complete. So we have the real numbers. Rather than doing a circle for the real numbers, they've done a square because all numbers fit into the real numbers. And inside the real numbers, I have my surds and I have my rational numbers Q. And then in here, I have irrational numbers that are not surds, for example, pi. So irrational numbers that aren't surds would go in here. So we've got Q, then we've got Z, my integers, and finally I have n my natural numbers, and I'm asked to fill in. So 3/4 is a rational number, but it's not a whole number. 3/4, not 3/5. B, the square root of 3. It's irrational, and it has a root. C, 5/2. I should have given a bit more space. D, the square root of 5. I hope you can see that clearly enough. The square root of 144. Now, if I were to put that into my calculator, I would get 12, which is a whole number. And not only that, it's a whole positive number. So the square root of 144 would go here. -8 is a whole number, but it's negative. 14/2. Yes, it's written as a fraction, but it can be written as a whole number. Definitely should have done this a bit bigger. Pi. Pi is irrational, but it's not a surd. So it's out here. 5 pi, 5 multiplied by pi, is irrational, but it's not a surd. And finally, the square root of 3 squared gives me 3. So that's going to go in my natural numbers. The square root of 3 squared. I should definitely have given more space for the natural numbers there because 3 of them went into the natural numbers. Okay, just focus that a bit. And those are the answers. Okay, so let me know if you have any questions on the homework. Thank you very much.